Hey, hello viewers. Thought I'd just share a day in the life at Switch Automation here, normalizing data and getting it into the platform so that we can actually do big analysis on the data points that come in from different building systems integration. This is a smaller portfolio that we have, and all the data we've already brought it in. It exists on the platform, but I thought I'd share some behind the scenes of how we create and normalize the data in the platform across many manufacturers, across many different sensor point descriptions. So 14 sites, 453,000 sensor points across 20 manufacturers. If you have a look here, if I pivot by vendor, you'll see some of the familiar names that are associated with building controls. We've got ABB, Honeywell, Johnson Controls, Lutron, so they spread across metering, controls, and in here is where I guess the magic happens. You know, we apply some machine learning techniques, quality assurance, so that we validating and verifying that when we're naming these points and ingesting the data, that consistency is maintained, so that you can do, you know, optimal analysis of the sensors once they're in across different manufacturers. A whole lot of model numbers as well, so we take in, you know, all sorts of parameters from any of our integrations. This one, if I hadn't said it already, this is on BACnet only. We do have API integrations for some of the other items, and particularly the utility bill integration. But here's all the equipment types that we've found for this portfolio, and that's come out of all of this connectivity. I'll spend a moment on the connectivity piece. This is Switch DX Cubed, which you may have heard of before or seen videos about, but this is really coming from the Switch operating system. The Switch operating system can be in a virtual environment, so it could be deployed as a container in a virtual environment. It could be just on our IoT appliance that we'll ship to site and install, you know, at the edge. Once we've instigated a scan, we're able to identify how many devices we're seeing, how many point counts we're seeing, the protocols that we've identified. So some common ones that I'm sure if you do anything in building technology, you know BACnet, you know MQTT, you know Modbus. Obviously Fox here is a proprietary protocol. So from this is where we start some of our data normalization and machine learning. We can identify the categories of the integration that we've seen, or the devices that we've seen. We'll map out subcategories for this as well, and also we're going to slice it by manufacturer as the manufacturers become apparent. So if I go back to the list, this is where it's really important just to show how different data comes in from all of these controllers. Like the object name is quite an important field that we'll use, but just for example, I'll pivot on a couple of these just so you can see the differences that we get from all of the different controllers. So within the object name alone, there's 100,000 different types of object names, and in the descriptions there will be, even though there was no descriptions for Lutron, there's often descriptions on other manufacturers. So there's a whole lot of, 13,000 different descriptions, and you can see here some of these do make sense, some of them don't make sense, and these are all the things that you do when you bring in that, and then we can apply to some of our existing models. But just to get into some of the specifics, is like set point is a classic. If I look up how many different set point names there are, you'll see here that to do any analysis on temperature set points that might be out of range, you need to be able to just persistently call it a set point, irrespective of how we're getting it in. But we do maintain and keep this as the set point, because the vendors who need to potentially fix, repair, configure these, this is how, generally they'll know it, because it's in the controller like this. So you'll see here from Johnson Controls, we've got, CLG set point, and that's cooling, I'm going to assume. Down here with Honeywell, we've got the room set point. So you'll see, and I'm sure there's probably some more manufacturers coming up soon, we've got the CO2 set point. So temperature set points, CO2 set points, airflow set points, they all need to be consistently named. I'm sure if I do temp, I'll probably see a few different types of temps as well. So I really think the value in normalizing the data is that then this is seamless for the end users. A temperature is a temperature is a temperature, as long as obviously the use case or the application is right too, because there's all sorts of different things, whether there is if it's a room set point, but this could be like this one's a temperature offset point. So they've all got different names and configurations, and for that very reason on the sites. But we will normalize that into the brick schema, so our tagging is very, very consistent, irrespective of how it's coming in from the edge. So that's out of 450,000 points, just a quick overview of why it's important to get your data standardized in one place, applying relevant tags so you can actually truly do big analysis across your portfolio, whether that's because you're chasing net zero goals, you might be running for energy efficiency, equipment performance, equipment life cycle, optimizing equipment performance. To be able to do that, you need to do that off the back of normalized data sets, especially if you're trying to benchmark sites against one another. You can't do that with data that has not been normalized and cleaned up. So hopefully that was informative, and we'll see you on the next one.